Today we are going to see the most important algorithm for depth first search. Okay, and this algorithm is very similar to the breadth first search. Breadth first search. The only difference between depth first search algorithm and breadth first search algorithm is in breadth first search algorithm we will be using a queue. Okay, but in the depth first search algorithm we will be using a stack. Only this is the difference. Otherwise, everything is same. From queue will dequeue the element, but from stack will pop the element. These terms are very uh, different as compared to both of them. Okay. Now let's take an example. Let me consider a new graph A, B, C, D, E, F. Okay. Now here this is our going to be our graph. Now if you look at this graph, obviously there are 6 nodes or vertices, right? And these 6 nodes will be mapped to make the mapped so that we can implement this in programming. Okay. So I got A will be mapped to 0, B, C, D, E, and F. So 1, 2, 3, 4, and 5. Similarly, after mapping, you need to write a adjacency matrix, which is mostly similar, which is exactly similar to the BFS which I have explained in the class. Now, if I got A is nothing but 0. Let me mention with the small letters here 0, 1, 2, 3, 4, 5. Okay. So 0. Now 0 is having edges with 1, 5 and 3. 1, 5 and 3. B 1, C 2, D E F. This is 3, this is 4 and this is 5. Right. And B is having edges with 0, 2 and 4. So it is 0, 2 and 4. And 2 is having edges with 1 and 5. 3 is having edges with 0 and 4. 4 is having edges with 1, 3 and 5. 1, 3 and 5. And 5 is having edges with 0, 2 and 4. 0, 2 and 4. Okay, after writing this, we'll start the algorithm. Okay. Now, what the algorithm says, initialize all the nodes to the ready state. There are 3 different states. Status, state 1. State 1 is nothing but ready state. This is ready state. And state 2 is nothing but, you can see, state 2 is nothing but the waiting state. Status 2 is nothing but waiting state. So it is waiting state. And then the third one is status 3. Status 3 is nothing but the processed state. Processed state. You need to understand this. Before adding any element into the queue, we'll call it as ready state. Not queue. In this case, we are going to add it into the stack. Before adding any element into the stack, you need to remember that is purely a ready state. And then waiting state. Waiting state is a element that is there in the stack. Okay. And then the third one is process state. Any element that will leave the stack is called as process state. If you know these three, then writing the example is very simple, right? So what we will do is we'll just go use a different pen. Initialize. In the initialization, you are going to initialize a stack. What it says, if you look at the algorithm, initialize all nodes to ready state. So there are 6 nodes. I am going to initialize with 1 1 1 1 1 1. There are 6 nodes. It is for 0 1 2 3 4 5. Or in other ways I can say this is for A, B, C, D, E and F, right? Now what we will do, we have got a stack. Actually this will not be stack, it is nothing but, see, we need to initialize status, so it should be a status, and initially stack will be empty. Stack will be equal to empty, right? This is what you need to initialize before starting the steps, okay? And then next what we will do, we'll go to step 1. In step 1, what it says, push the starting node A. Imagine that A is the starting node and you need to push it onto the stack and change the status to be to the waiting state. So waiting state is equal to 2. So what we will do is we will just try to push A onto stack, right? And this will change status of A to 2. So now can you tell me what is stack? Stack will be equal to 0. 0 is nothing but A. And then status is, this is 2. Status of A has become 2 now. Then this is 1 1 1 1 1, right? This is our step 1. Very simple. You need to push A onto the stack and then change the status of the element in the stack to 2. A very simple step. Now we'll go to the third one. Repeat step 4 and 5 until stack is empty. You need to repeat step 4 and 5, means step and this step should be repeated so that till the stack is empty. At present stack is not empty, so I am going to start these steps. So pop the top node n of stack, process n and change its status to process state. Here process is nothing but you are going to find the neighbors of n and push onto the stack all the neighbors of n that are still in the ready state. This is very important. If the element is in the ready state, then only push it onto the stack, else you should not push it onto the stack. You will come to know as we solve the example, and change their status to the waiting state. Any element that is just pushed into the stack, their status has to be changed to the waiting state, that is status is equal to 2. So according to fourth one, you are going to pop the top element. Actually pop itself says that you will be removing the top element. You need not mention this explicitly. Already pop itself says that you have to remove the top element. So you are going to, in the step 3, in step 2 what we will do, we'll just pop A and process it. Process it means you will just find the neighbors neighbors of A. Who are the neighbors of A? You can see the reason why adjacency matrix is written, because to find out this one. So 1 5 3, 1 5 3 are the neighbors of A, right? And then after that you need to find what will be stack now. So stack will be equal to, you have just popped the top element, this one, and so you are going to push these element onto the stack, 1 5 and 3, and then status will be changed to, if, as I said, if element is leaving, if element if element leaves the stack, status will change to status changes to what? Status will be changed to 3. So initially it will be 2. Since A has left the stack, we will have status of that as 3, and then status of this 1. Now you see, any element in the stack, any element in the stack will have status 2, will have status 2. So status of this will be equal to 2. Now status of 3 is also 2. Now here comes 2. Status of this is also 3, 2. And status of this 4 is what? 1, because no changes. Status of 5 is 2. So this is our step 2. You are going to perform these steps repeatedly again and again, right? So in step 3, what you will do is you are going to pop the top element. If you consider this as a stack, I'll consider this as the top element. Okay, this is the top element. So I'll be popping these elements. So here we are going to pop 3, because 3 is the top element. So 3 is nothing but what? 3 is nothing but D. So pop D and process it. Process it means you will write the neighbors. Neighbors of D are, who are the neighbors of D? Neighbors of D are 0 and 4. So it is 0 and 4. And then what will be stack equal to? See, recently you have popped this element. So these two are in the stack now. And you are going to push these elements only if the status of these element is equal to 1. But if you look at the status of this 0, 0, it is 3. So you need not push it onto the stack. Now what is the status of this 4? 0, 1, 2, 3, 4. This is the fourth element and the status is 1. That's why you have to push it onto the stack. You need to remember this. This is very important. If the status of a element is equal to 1, then only you are going to add it on the stack, else no. Okay, so status will be equal to now what? See, just remember this one. If the element leaves the stack, so at present A has left the stack and then D has left the stack. Only the status of A and D, 0, 1, 2, 3, 4. This is D, right? A, B, C, D. This is D. So this will be 3. Remaining all, this will be 2 because this is in the stack, and 0, 1, 2. 2 is not in the stack, 3, and then D just now has left A, B, C, D, E, F. So this is E is in the stack, and then F is in the stack. So it is also equal to 2. So you can see clearly, recently A, B, C, D. This is actually D. Status of this has been changed to 3, not this one. Okay, because that has left the stack now. Okay, again you observe the steps here. You need to pop a element, process it, find its neighbors, write the stack, write the status. This is repeated for each and every step. If you understand this clearly, then I think you will be able to solve such questions uh, better. Okay, now coming to the step 4, pop top element. Which is the top element now? Pop 4. You just process it. 4 is nothing but 0, 1, 2, 3, 4. So A, B, C, D, E. So pop E. Process it. You are popping E and you are going to process it. So who are the neighbors? Neighbors of E. Who are the neighbors of E? Neighbors of E are 1, 3 and 5. You can just note it down. 1, 3 and 5. If the status is equal to 1, then only you are going to add it onto the stack, otherwise no. Okay, so it is 0, 1, 2, 3, 4, 5. What is the status of this 1? It is equal to 2. Already it is there in the stack. So stack is equal to 1, 5. I have just popped this 4. I need not write it. Now what is the status of this 3? It is 3. So I will not be adding this one. Status of this 1, it is 2. I will not be adding this one. Status of this 5, it is 2. So I will not be adding this one. So we have got only stack is equal to 1, 5, right? And then status is status is equal to what? I have just popped E 0, 1, 2, 3, 4. I have popped this element, so the status of this will be changed 3, 2, 1, 3, 3, 2. You can clearly observe there are two elements in the stack. So two elements in the status will be having value 2. Okay, that is very important. You can see here there are three elements in the stack. So these three elements, this one, and this one, they are having values as 2. The number of elements that are present in the stack will have status equal to 2. Just remember that one, right? And then we'll go to the next step. Step 5. In this step, we are going to pop 4. We are going to pop this element, right? Pop 5. 5 is nothing but what? F. We are going to pop F and process it. So when you are processing it, you will be finding the neighbors. Neighbors of neighbors of F. Who are the neighbors of F? Just go back to your matrix. Neighbors of F are 0, 2, and 4. So neighbors of F are 0, 2, and 4. What is the status of this 0? It is equal to 3. So we are not going to add it on the stack. What is the status of this 2? 0, 1, 2. Status of this 2 is 1. So we will add this one. Status of this 4, 0, 1, 2, 3, 4. So we will not add this one. So how will be our stack now? Stack will be equal to 1, 5, and 2. Right? And then what will be status? You just observe which element you have removed. Fifth element. So this element is removed. So the status of that element will become 3. So it will be 3, 2. See, I have just added this 2. So this status of 2 becomes 2, 3, 3, and 3. I have removed this 5, so I should not write it here. That is very important. Do not do such mistake. Okay. So I have got only 2 elements in the stack. This is 2. So you can clearly observe this is first one and this is second one. So only they are having status 2 because they are in the stack. Now go to next step. In the step 6, you are going to find, in the step 6 you are going to pop the top element 2. So 2 is nothing but A, B, C. C you are going to pop C. C is nothing but 2. Process it. Process it. And who are the neighbors? Neighbors of C. Who are the neighbors of C? Just go back and check who are the neighbors of C. Neighbors of C are 1 and 5. So 1 and 5. What is the status of this 1? It is equal to 3. So we need not add it. What is the status of this 5? 0, 1, 2, 3, 4, 5. It is also 3. So we need not add it. So our stack will be equal to only one element, and then status is equal to, this is 3. What you have popped? 0, 1, 2. This element you have popped. So that will become 3, 3, 3, and 3. So fine. Now in the next step, I hope now you have understood how you need to do this one. So in step 6, you need to pop B, which is equal to 1. See this one, you need to pop only the element in the stack, process it. Then who are the neighbors? Neighbors of B are, who are the neighbors of B? You can just go back here and check. 0 to 4, 0 to 4. Can I add them onto the stack? You can see 0, 1, 2, 3, 4, 5. Status of 3 to 0 is 3, so not need not add it. Status of this 2 is 3, don't add it. Status of this 4 is 3, don't add it. So what will be stack equal to now? I have just popped B from the stack, so stack will be empty, and then status will be equal to what? 3, 3, 3, 3, 3, 3. 1, 2, 3, 4, 5. All right, and then just close this part. Now you can see initially we started with status 1, 1, 1, 1, 1. Now they have become 3, 3, 3. It means we have processed all the vertices. Therefore, DFS of the given graph will be which all elements you have popped. Just you need to record that one. All right. So first you have popped A. So the answer for this one is first you have popped A, and then after popping A, you have popped D, E, F, D, E, F, after F, C and B. After F, C and then B. So this is your required DFS. Okay. And if you understand this, then I hope this one will not be difficult. You can see here you are going to repeat step 4 and 5 until stack is empty. At the end we had stack empty, and that's why we had to exit from the algorithm. Thank you.